just in terms of the smart cities, right? We expect lots of different kinds of networks. We expect the neighborhood area networks. We expect the field area networks. We expect the traditional microcells and macrocells all to come together. And this is going to be in a smart city. Is going to be an interplay of license exempt devices and licensed devices. And so this is going to create a pretty interesting RF spectrum, which is going to be pretty challenging, just in terms of managing, right? Because what may happen is that the, for example, Federal Communications Commission and Admiral Simpson is part of the FCC, right? So they may say that, like, okay, fine, for the IoT devices, we are going to manage the spectrum and create the RF mask, which is a little bit more relaxed, because the IoT devices, they're really cost sensitive. So, say for example, for power meters, for field area networks, they might create some requirement where it says that, okay, fine, because you're operating at a much lower power, and typically they operate at even 0 dBm, you're going to create a pretty relaxed mask. But now you can imagine that, like, thousands of these devices, they come on at the same time, and now they suddenly can increase the noise floor, right? So, and say, these devices are operating in 900 megahertz spectrum, which is typically used on an unlicensed basis. But that 900 megahertz spectrum, it's the upper UHF, and so that has got the ability or potential that it can proliferate, and it can spread in the lower part of the 600 megahertz or 700 megahertz spectrum, where you have the 4G network connectivity. It can spread in the L band, where you see DoD applications, right? So, for example, FAA has got the ADS-B spectrum that is used in that particular spectrum band, in the 950 to 1150 megahertz of spectrum band, or it has got also Link 16 and others, right? So, this has got a pretty wide implication. And the other thing is that new devices are coming in the market, right? So the new devices, for example, which are powered by this new technology called direct digital transceiver. One of the companies that makes this direct digital transceiver is the IQ Analog. It's a startup which is based in California, and their devices can actually transmit and receive from UHF to K band. So you are no longer limited to any spectrum, and so that means that now you can actually create radios or sensors that can go from UHF band to K or Ka band. Um, it has got two things or two implications. One is a good implication that means that you're no longer restricted to the spectrum that you've been assigned. The other implication is, of course, that now anybody can come in and use that spectrum. And so this is going to create another issue that needs to be taken into account. Millimeter wave band brings its own challenges, right? So we keep talking about 5G and millimeter wave band, but millimeter wave band is, extremely uh, flaky in terms of the environmental effects, right? So a little bit of fog, or a little bit of rain, or a little bit of foliage can create lots of issues. And one of the main uh, issue when it comes to deployment of 5G networks, and especially massive MIMO techniques, is that when it's a good thing for people to design them in the lab, and then the engineers who design them, because we are really excited by massive MIMO technologies. But it's the other thing when somebody has to come and deploy them right in the field, and you put the antenna array panel, and the antenna array panel is supposed to be like 10 degrees from the vertical, and but somebody misconfigures it, and it is no longer 10 degrees from the vertical, and so it doesn't have the same coverage area. um, and you're not going to be, once you put that, how are you going to measure and figure out that this particular panel has been misconfigured? And that's the reason why the radio signals are not proliferating, right? So this brings in a pretty interesting aspects, not just in terms of, like, misconfiguration of the radios, but also misconfiguration of the antennas, because slight misadjustment or misalignment is going to give you a completely different coverage. Uh, so how do you know, right? And so there might be some applications where you might want to figure out, hey, how do you measure this? So I know that quite a few companies are trying to figure out how to, how to make sense of this misconfiguration of the antennas, right? So that is one aspect or one major problem that we might face.